describe a formula here? What do you think? What do you guys see? You see the letter P, you see a what? L, you say what? W. These are sort of the variables. And you say, well, what are variables? Well, those are concepts that can vary. So what do you mean they can vary? Well, this formula comes from, for example, the concept, first of all, of a rectangle. And a rectangle has what? A length. It does have 4 sides. The longest side is called the length. The shortest side is called the what? The width. And what happens here is simply that if I want to determine the value called the perimeter, P stands for perimeter. Do you guys know how you find from geometry? How do you guys find a perimeter?
Like that.
What is a perimeter? Do you guys know? You ever see that word before? Perimeter. What is that?
Area around.
Well, you see, the language is very. It's not. Let's say this. It's the distance. What? Around this area? Well, it's a distance around this shape. So if you were to walk, let's say you start at one corner, you walk this distance. How far did you walk? L. Okay, good. And then you went what? Down this distance. How far did you go? From here to here. How far did you go? W. And then you walked again from here to what? To the next corner. How far did you go here? Well, these distances are the same, so you went the same distance. It's what? L. And then if you walked from this point back up, how far did you go? You went the distance W. So if I say to you that the distance around this region, I don't want to use the word area, the distance around that region is L plus what? W plus L plus another W. That's called your perimeter, meaning the perimeter is really L plus W plus L plus W. Is that true? So when you go and you combine your like terms, what's L plus L? 2L. And what's W plus W? 2W, meaning we have simplified this equation, or at least the right side. We simplified this by combining like terms. Doesn't this look a little more simpler to use? Okay. Now, the reason we call these things variables is because they can be different values. They can vary. So, for example, they can give you, a rectangle that measures 5 inches in length, 3 inches in what? Width. They can give you a rectangle that measures maybe 12 feet in length, okay, and maybe 4 feet in width. Okay. You got to be careful. Got that other class coming in. I already told you guys about that class. It's a little shady. Let me put this away now. All right, I'm just joking. Sort of. All right. Let's look at this example here too. Let's give you another rectangle. Okay, I just want to introduce the concept for you. This rectangle. Let's talk about some units of length. We got inches. We got feet. We have what? Centimeters. We got miles. What else do we have? Yards. Kilometers or meters. Okay, let's say this is going to be, I don't know, how about 3.8 meters? And let's call this 1.2 meters. Okay. They want you to determine what? Determine the perimeter. Determine your perimeter value. We'll represent that with P. So there's a couple of ways we could do this. If we know the formula, P is what? 2L plus what? 2W. You guys okay with this one? What do I replace with L and W? What do we put? What's L? Is that 5? What's W? Is that 3? Is that true? So we're going to substitute the value of 5 for L. We're going to substitute the value of 3 for W. What that gives us over here, let's put it down here now, is your perimeter will be 2 times 5 plus 2 times what? Not W, but what?
3.
But 3. Do you guys know what you use now here? What do you guys use? Huh? Yes, you use what here? Order of what? Operations on your right-hand side. Use order of operations. So this is the first part of introducing you to formulas. The first part is actually just plugging in values and using order of operations, meaning what's your perimeter going to be for this problem here? 2 times 5. Remember, what's order of operations say? You got addition, what else? 2 multiplication. Which one do you do first? Multiplication, which one? The one on the right or the one on the left? Oh yeah, what's 2 times 5? This is 10 plus 6. What's 10 plus 6? That's 16. What's the units that you were of distance? So the answer here for this question is 16 what? Inches. Okay, you guys okay? Is that easy? Or is that hard? Is that easy? What do you guys think? Huh? Remember, you want to appreciate everything that's easy now, because what's going to happen in the future? We always take a step up. You know, we kick it up a level, right? So appreciate that. All you're doing is plugging in the quantities. And what I'm saying is, these values vary. L and W could be any values you want, because there's different models that exist. So you plug in those values and you can deduce the perimeter. Okay? So look at the next example. If we use that same concept here, the perimeter is 2L plus what? 2W. What is L in this example? 12. Replace L with 12. What's W in this example? 4. Can I erase this right here? Do you guys have this in your notes so I could use the same area there of the board? Okay. So I'm going to do this now. Notice what I'm doing. I'm going to say the perimeter equals, P still equals 2 now what? Isn't that 2 times what? 12 plus 2 times 4? And what do you guys get here when you do this? What's using order of operation now? Perimeter is going to be 2 times 12 is 24 plus 2 times 4 is what? What's 24 plus 8? It's 32. What are the units? Feet. So your perimeter is 32 feet in this example. Easy, is that right? Plugging in the quantities using order of operation. All right, let's do the last one here. Okay, so I'm going to erase this here on the board. And I probably shouldn't have, but I'm going to. Let's do the last one. Right here. Yet again, what's the formula for the perimeter of a rectangle? P equals what? 2L plus 2W. This example, what's the length? 3.8. Good. What's the width? Good. So if we really look at this, we have the perimeter equals 2 times 3.8 plus 2 times 1.2. We're still going to use again what? Order of operation. Okay? Is that somebody's car they're still in? Jeez. All right, what do you guys do first? Okay, what's 2 times 3.8? 7.6. Okay, you guys know this. This will be 7.6 plus, what's 2 times 1.2? 2.4. Do your addition now. What's 7.6 plus 2.4? 10. What are the units? Meters. Your perimeter is 10 meters. Okay? So, what I'm showing you here, this is only one formula relating the length and width in the concept of perimeter into an equation. Formulas, we have tons of formulas. Okay? And you may say, oh, Mr. Judge, why do you math guys and girls, why do you math people always, why do you have so many formulas? Does anybody know why? Why are there so many formulas? Huh? What do you think? To make it easy to solve? No. Why do you think there's just so many formulas out there? Do you guys know, what are you majoring in? What's your major? Nursing. Do you think there's any formulas there? There is? Why would there be formulas in nursing? What are you majoring in? What's your major?
Me? Oh, are you looking Oh, I can't tell you're looking.
Can't tell? I can't tell either. I'm blind. I can't even see. I'm deaf and I'm blind. What are you majoring in? I just see red. She looks at her shirt. I know. What's red? What's red? What are you majoring in? Pharmacy. Do you think you use formulas there?
The formula, you can use it in many situations.
Yeah.
Let's say you will buy a house.
Mm-hmm.
You need to know the perimeter house. Then use the formula. It's all right.
Even, you guys know, even if you're going to compute the mortgage payment, is that a formula? So what I'm saying is, a lot of your majors, one of the reasons why in algebra they want you to deal with formulas the way you do, is because you use them in the topics you what? Study. A lot of science courses, business courses, a lot of the courses you take, nursing courses, you're going to have formulas that you use. And so you have to be proficient in how to use them. And all they do is relate quantities with one another. And every formula actually can be derived. The same way I derived this formula here for you guys is a definition of a perimeter I use to deduce that formula. Every formula that exists can be deduced or has been deduced. It's not made up. It's not arbitrary. They relate quantities. And so quantities are all around us. So we have to be able to deal with that and not get nervous or scared and go, oh my God, here's a formula. I don't just do formulas. I just stay away. You can't look at it that way because everywhere you go, there's going to be a what? Formula. And everything you study, there's going to be a what? Formulas for you guys to study. Do you guys know that? So it's going to be just the name of the game. So it's not really, ironically, the math people that say to you, oh, guess what? We made all these formulas. No, they're formulas that come out of a lot of different settings that are used. We just, have them all together, I guess. We as math people, we're the ones who work with them or actually show you how to work with them. Okay, but they're actually, if you want, don't get mad at me then, what I'm saying. Get mad at your nursing instructors. Get mad at what was your major again? Pharmacy. Get mad at your pharmacy instructors or that discipline, our chemistry. It's these guys that are doing it. It's just the math people. This is our specialty. You know, we can work with any formula. All right. So it's true. It comes out of your discipline. What time do we have? What time is it now? What time is it? 35 when we get out at 50, right? Okay, good. So let's look at some formulas. Some of you guys may want to print out that formula sheet. Okay. I know I did. And, it does involve some reading. It's not such a big deal. Let's look at some more formulas here. Well, it's not exactly word problems, but they're problems that involve words. When we say word problems in algebra, we're very specific. There's number problems, there's mixture problems, there's distance problems, there's geometry problems. You know, they're very specific. But these are just simply settings that, you know, for example, what should we use here? The wavelength measured in meters per cycle of a musical note. So here's our first example in the formula handout, okay? They're saying W is a wavelength. W, for a musical note, is given by R over what? F, bless you. Where R is the speed of sound in meters per second. R is the speed of sound. Who would have ever guessed? Okay, we don't have to necessarily know that to use it. And that's what we're going to do. So we know R. What is R again? This is the speed of sound. And it has its associated units. You know, it says R is the speed of sound in meters per second. Okay. What is F? Let's see. The wavelength is W in meters per cycle. So this is called, W is called the wavelength. So that's good to know. And that's measured in meters per cycle. Okay, that's good to know. And you guys know what F might be? What do they say? F is the frequency in cycles per second. F is the frequency. And that's measured in what's called cycles per second. So yes, we did have to use some words to do what? To read what these quantities represent, because we weren't born knowing what these quantities represent. You know, you may not have woke up this morning and said, I know what these represent. That's okay. You can still work with this. Okay? So, let's see what they say. If the speed of sound in air is 344 meters per second, what did they just tell us? The speed of sound in air is 344 meters per second. Is that W, R, or F? R. What is R then? 344. And you may notate the units. They may say, okay, that's in meters per what? Second. That's consistent. Okay, we got that R value. They're going to say, what is the wavelength? Wavelength. They're saying, what is W? Sometimes I do this. What is W? What is the wavelength of a note whose frequency in air is 25 cycles per second? So they told me frequency is what? 25 cycles per what? Second. Well, that's consistent. That's my F. Frequency. Do you guys know the equal sign, the code word in English for that equal? Do you guys know? I mean, equals or equal is what you're looking at. But we also have another word that represents this equal. What is that? Good. The word is the same as, which is short for what? Is. I bring this up because they're saying frequency is 25. R is 344. You see what I'm saying? This problem is no different than the one you just did earlier. It's no different. All you have to do, though, now is what? Plug in what values? What's the model? W equals R over F. Good. What do we do now? We replace R with what value? 344. Good. This is 344. We replace F with what? 25. Is that true? Okay, and so if you take a closer look at this, we get W to be 344 over what? 25. Do you guys notice anything about this? What you would do now, just like what you did before, okay, is use what? Order of operation. Now the good news is there's only one operation to do. What's the operation? Division. Now, here's what's going to happen. Sometimes, or a lot of times, or sometimes we should say, this division is pretty what? Easy to do. You got a fraction. You go, well, Mr. Judge, I thought you told me I could leave my answer as a fraction. Well, you can. As long as it's what? Reduced or simplified. But you may look in back of the book and you say, okay, this is going to be what kind of units? W is measured in what? Meters per cycle. So this would be a meter per cycle unit, by the way. You're looking back of the book. Let's say you don't see a what? Fraction. What might you see? Probably not a mixed number. What will you guys see next? A decimal. That's true. So let's double check. 25 goes into 344 how many times? 25 goes into 25 goes into 34 what, once? 1 times 25 is 25. Let's do our long division. And I get 90 what? Is that 94? Hold on. 94. Let me be careful. Let's not speak in. This is 2. I borrow. Oh, it is 94. How do I know the answer? Weird. Okay. 25 goes into 94 how many times? Is that 3? 3 times 25 is what? 75. Subtract. Put your decimal. Put your decimal. What's this going to be? 8. 9. 19. Bring down to what? 0. 25 goes into 190 how many times? 7 times? Okay. What's 7 times 25? Is that 175? Subtract, what do you get? Is that 15? Uh-oh, we're running out of space. Is that 15? Okay, what do you do now then if I got 15? Bring down a what? Another 0. And now 25 goes into 50 how many times? Is that 6 times? Okay, and then what's 6 times 25? Is that 150? Subtract 150, you get a 0. Hold on, let's write it over here. W is 13 point what? 76, and that'll be meters per what? Per cycle. So the answer is 13.76. As a decimal, you did the long division, not necessarily something we do like in algebra. It can be because we do want to get our hands on that value. And if it's a course you guys may study, maybe in science, you study this, they're going to probably want you to have a decimal value. But that opens the door into sort of, some slight issues. Sometimes you have repeated division here, right? Your decimals go on forever, or at least it goes on for a while until you see a pattern. So whoever's communicating this to you may say to you, we want you to approximate your answer to a particular place value. In this case, if they said approximate to the nearest what? Tenths. Well, how does that work? How does place value work? Here's your decimal. What's that first digit to the right? Tenths. Good. What's next? Hundredths, and then thousandths, and then 10,000ths, and so on. So how do you guys approximate this? I'd say you fix that 7 here. You look at the digit to the what? To the right. That's my eyeball. If that digit is a 5, 6, 7, 8, or 9, you add 1 to the 7, and you forget about this place value. So because it's a 6, what do? You add 1 to 7, and you get what? So this is 13 point what? 8 meters per what? Cycle. What if that digit, though, here that I'm looking at was a 0, 1, 2, 3, or 4? Well, you just simply drop this last place value where the eyeball is at, and you keep the 7. You don't change it. So if you're looking back at the solutions here, don't get so what? So concerned, and you go, Mr. Judge, I did my homework. That's the first problem, and they said the answer is what? 13.8. How did they get that answer when I have this beautiful fraction here that's not reduced? What they did was they divided, got a little messy down here, I know. And then they did what here with that answer? approximated to the tenths. Sometimes that happens there. They don't tell you exactly what they did, especially if the worksheet was created by who again? Some programmer somewhere. If it was created by Mr. Judge or a math person, what probably we would do? We would say, do the division and what? Approximate to the nearest tenths. So we'd probably be much more clear. Okay? Believe it or not. Okay, you guys okay with that? Is that easy so far or hard? Uh-oh, silence. That's never good. What do you guys think? Is that easy or hard? That's easy? Should we see some more formulas? What's today? Is it Tuesday or Wednesday? Tuesday. Okay, so I guess we're going to see some more formulas when? Tomorrow. Some of you guys, what you may want to do is download the formula sheet. Okay? Download the formula sheet for yourself. We're going to work with these formulas. I'll give this to you. Okay? And I'll see you guys when? Tomorrow, okay? Camera make you guys nervous? All right. Just, guys, we gotta make sure the audio's on. Okay. So recall, we're working with formulas. Formulas are just a way to relate quantities. There's a lot of formulas. Let's look at some. Let's look at the worksheet a little bit here. Let's give you another geometric formula. For here we have a picture of a triangle. Okay. Now the bottom length of your triangle is called your base. We represent it with the letter B. Okay. Now the vertical. How do you guys measure your height anyway? If you had to measure how tall you were, how would you do it? What kind of measurement would you take if you had to measure your height? Do you guys know? You take a strictly what? Vertical measurement. Vertical is up and down. So we call this the height of our triangle. We represent it by a letter H. Sometimes, okay, see how this works today. Sometimes you will see here this sort of mechanism that's trying to describe to you that the height of your triangle is H. Okay, and so we know that the area here is 1/2 base times height. Okay, you guys okay with this? So here's a formula. And if they tell us, for example, they may say, what if the base is, B is base. What if the base is, maybe 16 centimeters, okay? And your height, H, is, let's make the height what? Let's say 6 centimeters. Okay, so they're going to use the word base. They're going to use the word height. What do you guys know about equals? How do we describe? Yeah, it's the word is. Good. So let's start to kind of get used to this. So I'll say base, represented by the letter B, is 16 centimeters. Height is 6 centimeters. Okay. They're going to probably ask you what kind of question? They're going to ask you to determine the what? Well, what do you guys think? Probably going to ask you to determine the area. And you say, well, why is that? Because A equals 1/2 base times height, where A represents the area, okay, of the triangle. So as you guys know, what do you really do here? You guys know? What do you really do? How do you determine the area if they gave you the other two values, base and height? Right? All you do is what? Plug it in. I'm going to say to you, sometimes students say to me, Mr. Judge, how do I remember these formulas? And I always say, Every time you use them, you what? Write them down. Okay, so if you use it 20 times in a homework session, then you write it down 20 times. So plug in the base. What's the base here? Not 16? And what's the height now? Not 6? Okay, so you replace B with 16 and H with 6, and you have the area equals 1/2 16 times 6. And so you use order of operation at this point. Is that right? So here we're going to use order of operation. And then let's see, what do we get when we use order of operation? Right? What's 1/2 of 16? Right? Because don't you have multiplication? So which one do you do first? The one on the left? You work left to right. They have the same operation. So what's 1/2 of 16? 8. So then that's 8 times 6. And what's 8 times 6? Is that 48? What are the units? Well, the distance they gave you is in centimeters, okay, and I want to say to you, you're going to say centimeters to the second power. That the units are what we call square centimeters. Does anybody know why? Why do we call them square centimeters for these units, for area? What does that really represent? Do you guys know? What does it represent? Square centimeters. What do you guys think? Okay, so what you found here was the value 48. It's 48 what? It's 48 of these tiny squares that are measured in what? Centimeters. So that's a centimeter by 1 centimeter. Okay, so what they're saying here is that there's 48 of these little things here, these squares, that make up or cover the region of the triangle. This is only one square. How many do you have covering this triangle? 48. Here's another square. Okay? So to kind of let you guys know, remind you about the units, is that the meaning of 48 centimeters to the second power is really saying there's 48 of these tiny squares in the region known as that triangle here. Okay? You guys okay with that? So again, this is how we use the formula. There's a lot of formulas you guys use. Okay, so I can give you one more as a sort of review. Let's see if I can find an interesting one. How about this? We'll do this for the nursing majors. You guys know that there's a relationship between Fahrenheit and Celsius, right? What's the relationship? 9/5 C plus what? Plus 32. Okay, so if you give me a Celsius value, I can convert this to what? Fahrenheit. Okay? Because there's portions of the world that measure things in Celsius, and there's portions of the world that measure things in what? Fahrenheit. United States, we work in Fahrenheit. How hot is it today? Do you guys know what's the weather supposed to be like today?
82, 83.
82, 83 what? Degrees in what system? Fahrenheit. Anybody ever been to another country and you put on the news and you want to see how hot it was? And what did you notice? They said something like, oh, it's going to be 20 degrees today. Like, what are you talking about? It's going to be 20 degrees. It's 20 degrees outside? Well, what system is that in? It's Celsius. So notice, if Celsius is, C is what? 20 degrees. Remember, what are we saying here? That the Celsius measurement equals 20 because the word is stands for equal. They're going to ask us to determine what? Determine the Fahrenheit temperature. So once again, you replace C with what? 20. Okay, and now this becomes an order of operation question where the Fahrenheit temperature is going to be 9/5 times 20 plus 32. Okay. Now, what does order of operation say? Because this is where you use order of operation. What do you do first? Do you multiply or do you add? You multiply. And you multiply because multiplication outranks addition. So what is 9/5 of 20? Do you guys know what that is? How do you find that value? 9/5 times 20. There's a couple of things you could do, right? You could say 9 times 20, which is what? Isn't that 180 divided by 5 plus 32? And then what's 180 divided by 5? Do you guys know what 180 divided by 5 is? It's what? Is that 36? Do we second that? Anybody second that? I think you're right. So it's 36 plus what? 32. What is 36 plus 32? Do you guys know? What is it? What does Fahrenheit equal? Fahrenheit is 68 degrees. Okay? So as hot as it's been lately, I wouldn't mind a temperature today of what? 68 degrees. Okay? But if we were in another setting, another country, they don't work in Fahrenheit, they work in Celsius, so you might see, okay, 20 degrees today in the news really isn't 20 degrees in the United States. 20 degrees in the Celsius really becomes 68 degrees in the United States. So you have to be able to convert and use formulas, and this is in your science classes, you would learn that formula all the time and you use it. All right, anybody have any questions on how to use a formula? How do you use a formula then? Plug in your what? Values. You want to do one more? Oh, you like your formulas. Let's give you a nice, good formula. How about something that's known as, do you guys know your simple interest formula? Huh? Okay, let's write down the simple interest formula. Simple interest. Anybody borrow money? What do you guys think? Let's determine the interest when you borrow some money. Okay, simple interest formula looks like this. I equals PR what? T. Okay? Well, you guys know, what does the I stand for? Good. That's a good guess, right? The interest is, what does P stand for? Principal. Principal. What does R stand for? We call that the rate. And to be clear, it's a rate, it's an annual rate. And what about T? T represents time, and we'll call that time, it'll be, if this is an annual rate, this time will be in years. Okay? So here's how we can phrase a question. Sometimes they'll give you words, and this is not really word problems, so you don't kind of look at this and you go, oh my God, this is word problems, I don't do word problems. You could do it, okay? Meaning, they're going to say, what is the interest after borrowing how much money did you borrow? Anybody know? How much? $400. Okay. Let's say you borrowed $400. What's the interest after borrowing $400 at, what kind of interest rate? Let's say you put it on a credit card. What kind of interest rates do credit cards these days?
30.
Ooh.
I think it's like 21 to 25%.
Depends. Some are as high as 30. They get you really good these days. It used to be the worst they could do to you in the old days. It wasn't too long ago, though. So I say the old days, it wasn't even too long ago. It was about 20%. If you got hit for 20%, everybody was laughing at you. They said, "Oh, you're paying 20%." Even 18 and 19 was kind of high. Okay, these days, cards can be as high. I think I paid off a credit card a couple years ago. I opened it up one day, and it was what kind of interest rate? 30%. I said, how did this card become 30? You got to read the fine print. Who knows? Okay, so let's say you're borrowing $400 at, let's not do 30. Okay, let's not scare everybody today. At 25% what? Annual interest rate. So what is the interest after borrowing $400 at 25% annual interest rate? Let's put a comma here. Let's change that word after, and we'll say when. When borrowing. After how long? How many years did you borrow this, or has it been sitting there? Let's say after, 3 years. Let's assume you did not pay anything. Okay? For 3 years. We want to see the interest that was earned on your $400. Okay? This is found by the what? The simple interest formula. Okay? Obviously, it's a model that you may say, well, that's not realistic, Mr. Judge, because I'm going to make some payments. And you're right. And so this relationship becomes a little bit more complicated. We could deal with that. Not today, though. But you're correct if you said, wait a minute, this is kind of, I'm not going to sit on $400 for 3 years. I might make some payments. You're right. The reverse of that scenario can happen. And we'll talk a little bit about that, but let's do the calculation. You got your interest equals what? What's the principal? In other words, when you read this, what is the principal? It's the amount you're borrowing. Is that true? So in this case, what is the principal? 400. Good. So we know that PRT, my principal is going to be 400. If you want, we'll put that in red. So it stands out. Here's your principal. Now, what is the 25%? That's the annual interest rate. That's your R. Is that true? Now, what do you think 3 years means? That's your time. Good. So I'm going to put down here that the principal is 400. The annual interest rate is 25%. Do you guys know what 25% is numerically? 0.5. It's 0.2 what? 5. Move that decimal 2 spaces to the left. And what is your time again? 3 years. So here's what the bank's going to say to you. Okay, plug in your 400 for P, plug in the 0.25 for R, plug in the 3 for T, plug in these values, you get interest I equals 400 times 0.25 times 3. Notice this, ladies and gentlemen. Again, you got multiplication here. Order of operation says to do what? The one on the left. What's 400 times 0.25? Anybody know? How much? Is it 100? Okay. What's 100 times what? 3. Anybody know what that is? What's 100 times 3? How much is that? $300. So, ladies and gentlemen, the interest that was accumulated when borrowing $400, called the principal, at a rate of 25% for 3 years. You sat on that for 3 years. What does the interest become? $300. Okay, you guys see how that works? $300 is your interest. How do you like that? And we didn't even use the 30% credit card rate. That rate is for suckers. Do you guys know that? You say, what do you mean? Well,
well, I guess it's hard to say these days, but that rate is is a rate that's somewhat given to people in sort of more desperate situations. They give you that higher rate, so it's kind of an exploitation. The lower rate are people in less desperate situations, but they tie a lot of different things to this. Like if you miss a payment by an hour or by a second, your rate goes sky high to that magic 30. So they kind of kick that in, and I just want to point out to you guys so you guys understand how this works, because these formulas are real. They're real life stuff here. So that's the amount of money you have to pay before what? In other words, what's the new balance? We should say, what is the damage? What's the new balance on this scenario? Sometimes known as the new what? Principal. In other words, how much money do they say you really owe now? Yes. So you take the what? The interest of $300 and you add the original principal of $400, your interest in dollars, the original principal, how much you borrowed initially, and you get what's called the new principal. And what's 300 plus 400? You guys know what's the new principal? $700. So in other words, they now say to you, you don't owe us $400. That was what you originally borrowed. After 3 years, you accumulated $300 in interest. That's almost the same amount, isn't it? You now owe $700. So you have to pay off that $300 before you actually can start paying the original amount of money you owe. $700. Okay, so does that feel like a real formula now in your life? It should. Okay, is that kind of as real as it gets? That's real. $700 you now owe. Okay, now let me reverse the scenario on you. The banks, do you guys know when you put your money in the bank? This is a scenario if a bank lent you some money. But if you put your money in the bank, do you guys know that you get the same what? That the scenario works for you as it works against you? Do you guys know what I'm talking about? No? Let's say, for example, you deposit. Instead of you borrowing, you open an account, a savings account, checking account, and one that earns interest. So let's say you deposit. How much money are you going to deposit?
25 bucks every 2 weeks, so 50 bucks a month.
Give me, what's your initial, how much money are you going to put in there? Oh, you're going to put in some $500? Let's say you deposit $500 at a rate. What kind of annual interest rate do they give you? Huh? They're not giving you 25 or 30%. Huh?
2.5%.
You're lucky. You're 8.5? Yes, at 0.5%. See, at an annual interest rate of 5%. That's 0.5%, ladies and gentlemen. Compare that to the 25%, the term that they actually use to borrow. They go, you know what? When we give you money or lend you money, we're going to charge you 25% interest. When you lend us money with your deposit, we're going to give you what? 0.5% interest. Is that fair? No. Let's see what this is after, let's say, 3 years. All right, after 3 years. It's not very fair, is it? It's not fair. Those banks. Here we go. So if we use our, by the way, what do you think the principal is now? Do you guys know, if I write this down, that my interest still is PRT in a sense? What's the principal now? 500. Good. What's the annual interest rate? Is it at 0.5%? Okay. So it'd be 0.5%. What's the, By the way, what's 0.5% as a decimal? Let's write this down. Your principal now will be 500. Okay? Let's write down the details because this is how you get your answer right. So your principal is 500. The interest now, 0.5% becomes, move this decimal 2 spaces to the left. How many zeros do you have? 2 zeros, a 5. And how long are we going to leave this here again? 3 years. So what I want to say to you is when you plug in this interest rate value, don't put 0.5%. You have to use the numerical representation of 0.5%, which is, I'll put it up here, 0.005. Again, time is 3. So let's see what kind of interest the bank's going to give us on our $500. 0.005 times 3. Again, you use order of operation. What does order of operation say to you? Yeah, multiply before you, well, multiply the one on the left first. What's 500 times 0.005? What is it? Is it 2.5? Anybody second that? Is that true? 2.5? How do we know? You do your algorithm, multiplication algorithm. All right, what's 2.5 times 3? 7 point what? 5. Is that right? Let me double check the arithmetic. 500 times 0.005. Let's do our algorithm. 0.005 times 5 is 25. 0, 0, there's 3 zeros. And then there's another 3 what? Zeros. Let me add 0, 0, 5, 2. All right, there's 0 there. How many decimals again? 3. 1, 2, 3. 1, 2, what? 3? 2.5? You guys are right. You mean after 1 year, $500 at a 0.5% interest rate only gives me $2.50? And so I have to leave that there for 3 years to make how much money? $7.50? So look at this. Here's what the banks say. Guess what? Okay. Don't worry. If you deposit with us $500, we're going to pay you a 0.5% interest rate. So on your $500 every year you make $2.50. After 3 years, which is times 3, you're going to have how much money? Well, you have $7.50 in interest. What's your new balance? Do you guys know? Because you still have the money there. What's the new balance? 500 plus what? 750. Your new balance is 500 and what? $7.50. That's your new balance. In other words, your money grew. Okay? After 3 years, your money grew. Your 500 grew to $507.50. The bank, when they lend you money, their money grew to how much? $700 after 3 years. Their money almost doubled. You see what I'm saying? All right. This is how it works. These are very realistic examples I gave you. Okay, that 0.5% is probably a savings account. Did you get that in a savings account?
I got it in a CD.
A CD? Oh, that's even worse.
And it's locked for a few more months.
Oh, I didn't know that. Wow.
But 500, they wouldn't give you 0.5, they'd give you less than that.
They would?
Yeah, because it starts off as, I think, 1,500 that they give you 0.5.
Yeah, I know. There's tiers. And in fact, they'll give you a higher rate if it's locked up longer, too. Yeah, I know there's tiers. So here's what I'm saying to you guys. I don't know. What do you think? How does that seem to you? Do you like that idea? You don't like it? You guys don't like this? Does it seem unfair?
They should switch it.
They should switch it?
Yeah.
What do you guys think? How about if we just let the banks write all the rules from now on? Is that a wonderful thing?
They already do.
Yeah, they already do that.
Shh, I know. They already do. Did you guys notice that? They already write the rules. We're going to have a presidential election soon. What does one candidate say? He's going to let the banks what? Write their own regulations.
Well, he is.
Well, they both could do something about it. Okay, so here's kind of how it works, so you guys know. Horrible. No wonder you guys hate mathematics. Right? It's full of good news. All right, well, this isn't the only way we work with formulas, by the way. Okay? What happens is this. This isn't the only way you work with a formula. Let's write down this formula here, and let me say this to you guys. Let's start off with another example. Let's start with something pretty simple. Here's the formula for the area of a rectangle. Okay? What we're going to look at now is they're going to ask us to solve for, if you read this, it's already solved for A because it says A equals. So we're going to have to solve for what? Another letter or another quantity. Okay, what do you guys think? If we're going to solve for L, what do we want to see?
We want to get L by itself.
Yes, we want L by itself. We want L equals something. That's the idea.
A divided by W.
Okay, so you're going to look at this now. Okay? You look at the fact that this is L with a W. What does that mean? L times W. Is that true? So if you're trying to get this letter by itself, and you know that it's being multiplied by W, how do you undo multiplication? Division. Good. You guys okay with that? You always want to remember that. It doesn't have to be a number. It could even be a letter. So if you have the fact that there's a letter multiplied to what? L, the variable you want to get by itself right here, you undo that multiplication of W to the letter L by dividing both sides by the letter or the number, doing the what? Doing the multiplying, what you're trying to undo. And what you see here is what? By the cancellation principle we work with, you now get A over W equals what? L. Did you get L by itself? Yes. Say L is alone. Good. L is alone. You're done if you write this as your answer. You're also done if you write this as your answer. In other words, we can actually say it the opposite. In other words, A divided by W is L, or we can say L is A divided by W. Okay, so did you guys solve for L? Say yes. Yes. That's what you have to do. And you may say to me, well, Mr. Judge, why do you have to do that? Well, because sometimes they'll say to you, let's note, sometimes they'll give you a nice rectangle and say, okay, this is supposed to be length, this is supposed to be width. They're going to tell you if the area of a rectangle is, let's say, 35 square feet, okay, and the width is 5 feet, they may say, what is the length? You're busy writing this down. You're busy going, oh, I know that area is related to the product of length times width. You notice they gave me an area value. They say area is 35, which means A equals 35. They also say the width is 5, which means W is 5. Okay? So there's two ways to go about this. One way is to notice they gave you A, they gave you W. They gave you those quantities. You need L. And notice there's no coincidence that they're asking you for what? The length. That's not a coincidence, ladies and gentlemen. They're not going to ask you for the area or the width because they gave it to you. So they want to know what in the world is L. We don't know this. One way is to solve this for what? L. And so we know L is A divided by W. A here is 35. W is 5. So what do you guys know? What does that mean about the length? The length is 7, and this is in feet. So you're able to answer the question by using the relationship that the length is the area divided by the width. Okay, this is one way we go about it. I'll say, let's note, here's another way. Sometimes people just simply do this, and that's okay. They'll say, I know area is length times width. What was area again? 35. What was width? 5. Okay. So they say, I have 35 equals L times 5. Well, we really don't write our what? Our terms this way. We'll say 35 equals 5L because the order in which you multiply doesn't matter. This now looks more like a term we work with, right? 2x, 3x, not x2, not x3, 5L. And then what do you think they do now?
Divide.
Good, they solve for L. Okay? So this is kind of stuff that you're going to need to know how to do because you take those other courses like finance or pharmacy school stuff or nursing and divide both sides by your 5. And what do you guys still get? 7 is L, or L equals 7, and that's in feet. So there's two ways to deduce this answer. One is by solving for L directly. Now our focus from now on isn't going to be necessarily this other alternate method, although you can use it if you decide. They're going to ask you simply solve for a variable with a formula. And that's what we want to work with. Okay, solving for a variable. But does anybody have any questions on this that you just seen? You sure? There's no questions? All right. Okay, so let's get rid of all this and let's work with some solving for we call that really solving for the indicated variable. Okay, so you're going to get formulas. I'm going to say solve for the indicated variable. This is actually pretty, sometimes students have trouble with this. How about if I give you that interest formula, I equals PRT. They're going to say to you, solve for the indicated variable. They may say, solve for time, T. Okay, so they want you to solve for the letter T, where I equals PRT. They want you to get T by its what? By itself. You with me on this? So let's do this. I is PRT. Can you guys tell me what's happening to T? You guys know you got T here. What's happening to it? What are the operations? Because you have to undo those operations, don't you? So by undoing them, you have to know what's happening to T in terms of the operation. What's happening to T here? It's being multiplied by what? By R. Is that true? So I'm going to divide both sides by what? By R. Everybody okay with that? What happens by the simplification property that we studied? What goes away? Doesn't your R's go away? Right? The same quantity on top and bottom we can cancel. You guys with me on that? But then what do you guys notice? I didn't cancel the P, did I? The P didn't go away. So I have a P times T now. What do you think I should do?
Multiply P amount.
What do you guys think? So if this is P is being multiplied to T now, how do I undo multiplication with P? The same way I did undid the multiplication with r. I divide by what? P for both sides. What happens over here? Gone. Notice, can you cancel any of these letters? I, R, and P? Why not? Why can't you cancel them? They're different. Good. They're different. Thank you. So I divided by PR equals what letter again? T. Did you guys solve for T? Yes, you can say T is I over PR. And so, ladies and gentlemen, this is a formula that represents or relates time, directly in terms of the interest and the principal and the rate. So if you had to find a time, well, you could use this version. Okay, you guys okay with that? Is that easy or is that hard? All right, let's see if you're awake. Typically, students actually miss some of these. Maybe you guys will be different. How about 1/2 base times height? They want you to solve for base. Solve for B. What would you guys do here? What do you guys think? What's happening to B? Right, if you look at this, you got to look at the operations around B. What do you guys think? What are the operations around B? It's being multiplied by what number? 1/2 on that left side, right? What else? It's being multiplied by what? By H. So let's kind of deal with this one at a time. Okay? Let's do it this way. If I know that B is multiplied by the 1/2, how do I undo that? I can divide. Is that true? I'm solving for B. I can divide both sides by 1/2. That's true. That can happen. But who remembers that sort of special situation we've seen when we solved equations? Yes, you could do what? You could divide both sides by 1/2, or you could multiply both sides by what? The reciprocal of 1/2. What's the reciprocal of 1/2? Good. So if I multiply both sides by 2/1, do you guys notice what happens? What's the product of reciprocals? 2/1 times 1/2, or the number 2 times 1/2? This is really what? 1. In other words, the 1/2 is gone. How do I multiply a whole number by a fraction? This is product in the numerator. So this is 2 times A divided by 1. Ladies and gentlemen, you are really looking at what? 2 what? 2A, good. And that equals the B times the H. So you have your B here now. And you're almost there. Do you guys like that? I know I do. You guys need to love this because you could get it right. You guys could do this. It's not impossible to do. You could do it. Now what happens? I'm trying to get B by itself, right? Yeah, because H is being multiplied to the B. Divide both sides now by what? By H. What do you notice? H's cancel. You get what? 2A over H equals the letter what? B. You're done. You can say this as an answer if you like, because you got B by itself. Sometimes we write it as B is 2A over H, and what? You're done. Either way. So you got the base by itself. So the base is really double the area divided by the height. You solve for the indicated variable. Okay, notice what's the key to all of this? If you had to summarize this to somebody you knew or somebody you loved or whoever your family or you're at a party and this topic comes up, what do you guys say? You guys know how you solve for the indicated variable? You have to know how to solve equations. In other words, how do you undo multiplication? Division. Is that true? You guys okay with that? We got to do it to both sides. So notice we really undid multiplication here. How do you undo, for example, if they said P equals A plus B plus C. In other words, you may have, ladies and gentlemen, a triangle where they say, this is my base, this diagonal distance is A, this diagonal distance is C. They may want you to solve for the, let's say they said solve for C. They want you to solve this for the letter C now. You got to get C by itself. You with me on this? This is easy. You guys could do this. P is A plus B plus what? C. I want to get C by itself. Does anybody know, if I want to get that quantity C, that letter by itself, what's happening to it? What do you guys think? What's happening with that C? The letter B is being added to C. Is that true? So I have to undo this letter B that's being added to C. Not just that, you have a letter what? A being added to C. Is that true? So how do you undo both of those?
Transition.
Yes, you can do either what? Subtract both A and B to both sides. Is that right? What do I like to do? Good. You can translate. Translate the A. Translate the what? Translate the B. Do you guys notice the signs in front of both these A's and B's? What are they? Positive. So if you move them to the other side, where are the signs going to be now? Am I moving the P? Nope. So P is still here. P is here. A is now, I'm going to put it in red to emphasize the sign change. I'm going to put it in red to emphasize the sign change. This equals what? C. And ladies and gentlemen, is C by itself? So you're what? You're done. So we can say C is P minus A minus B. I want to warn you, tell me if you guys know, why can't you combine these terms? You got a P, you got an A and a B. Why can't you combine them? They're not the same. They're not like. So you're what? Done. What do you guys think? Is that hard? It's not hard. You guys can do this. You know, and so sometimes when students miss it, it kind of breaks my heart because it's like, wait a minute. You know, you can solve that for C. You translate the other terms. Right? You can undo multiplication. You use division. But let's now see if you're really awake. Okay, because we're solving for an indicated variable. We're working on this worksheet. I'll do like number 11 for you. You know, number 11, they have this. They have a combination now. 11 on the worksheet, you got x equals v plus, what is it? W plus y plus z. So x equals w plus y plus z divided by 3. And I'm going to say to you, sometimes as an exercise, they will put formulas down here or relationships down here for you to solve for an indicated variable where it doesn't even have a phenomena that it's associated with. It's not like this, where I want to find the perimeter around a triangle, right? Where how do I find a perimeter around a triangle? Oh, I walk A, I walk C, I walk B, I add those values. It's going to be P equals A plus B plus C. This is a relationship that actually, I don't even know what it represents. Who knows? But that's okay. I can still solve for, what letter do they want us to solve for? They want us to solve for Y. So this problem has a combination of things to undo. What's happening to Y? We want to solve for that letter. You guys know? So we have x is w plus y plus z, everything over 3. We're solving for y. What's happening to the y? What do you guys think? What happened? Yeah, it's getting added by w, right? W plus. Added by what, z? So you guys know, what are we going to have to eventually do? Subtract those two. Is that right? But what's in the way? That whole sum, or that whole thing, is being divided by the number what? 3. So we're going to have to undo those operations. Now, what do you guys think? Have you ever seen, what do you do first? Do you undo the addition by translation first? Or do we undo the division by 3 first?
Undo the division.
Have you ever seen us be able to translate when you're dividing by a quantity? Never. Is that right? You've never seen us translate when you're dividing by a quantity. So that should tell you something. Don't do what first?
Subtract.
Don't translate. Have you ever been able to get rid of a denominator like that? If you had something in the numerator divided by 3, could you ever get rid of that division by 3? The answer is what? How do you undo division? Yes, you undo division by what? Multiplication. What do you multiply by? By the number doing the dividing. In this case, what number?
3.
So I'm going to multiply the left by 3 and the right by what? 3. Be careful. This, ladies and gentlemen, as a numerator is still there. So when I multiply that right by 3, in some ways, if you wanted every detail, I'll give you every detail. 3x is w plus y plus z times that 3. 3 is a whole number, so it's times the numerator. Divided by what? The 3 that's down here. The whole purpose of undoing that division by 3 by multiplying both sides by 3 is so that the 3's what? Cancel by your cancellation property. The 3 is on top and on bottom. We can cancel. Do you guys know why? Because this operation is what? Multiplication. And this is thought of as a single quantity. That's why we put it in parentheses. So we can do the cancellation property. What we have then is 3x equals w plus y plus z divided by the number 3. Oops, 3's gone. Sorry. I'm already thinking of lunch. And guess what? You're in what kind of situation? You're in the translation situation. Do you guys see what I'm saying? Now we can translate the w and the z in the same way we did the last problem. And if we do that, we're going to move the w over here. Let's move the z over here. Do you guys know why I can translate? Why am I able to translate those two terms? Because I'm adding good. The operation to y here is addition. I can translate. If it's subtraction, I can also what? Translate. Just change the sign. So here's what I'm going to do. I got my 3x still there. My w, I'm going to what? Subtract. My z, I'm going to what? Subtract. And what does that equal? Y. Did I get y by itself? So you can say this is the answer, or you can say y is 3x minus w minus z. Okay, you guys okay with this? What do you think? Is this easy or hard? It's easy. But why do people miss it? Who knows? Maybe they think it's just so easy they don't have to study or practice. What time do we get out of here? Huh? 50? Good, we got time for some more. I love doing this stuff. I know you guys hate math because of all the reality. I love math because it takes me away from all the what? The reality. The reality is hard. The math is the easy part. Okay? Thinking about banks and all that stuff is... Woo! All right, here we go. Let me give you an example here. One that we looked at, the perimeter is 2L plus what? 2W. And we're going to solve for what? W. This problem is interesting. Okay? Yeah, how do we do that? We're going to try to, look at this. You know what I do? Like I said, it's very, sometimes, I actually circle that letter. When you first learn how to do it, you guys know, what's the benefit of circling that letter? It keeps you kind of reminded that you got to solve for that one. So you have to undo all the operations with y. And you say to me, well, what's going on with y? Well, directly, what do you notice? Isn't 2 being multiplied to y? So I'm going to have to undo that multiplication by 2. Of course, by doing what? Dividing by 2. We also have happening on this side with the w. You got 2l being added to it. Is that true? So what's going on with this w, we got to solve for that one, they want us to, is it's being multiplied by 2, we'll have to undo the multiplication of 2. But it's being added with the 2l term. This problem, there's 2 ways to do it. There's one easy way and there's one more challenging way. What do you think the easiest approach would be to do?
Divide by 2.
What do you guys think? What's the easiest approach? It's not divide by 2. What's the other option? Let's say you're on your homework and you look at this, you go, I'm not quite sure what to do. What should you try to do? Try something. Yeah, you could divide by 2, that's true. And we'll see that, but I'm going to tell you guys, try to do what? Wouldn't you like this 2l to be on the other side? Wouldn't you feel better if that term wasn't even there? You say, I really wish that term wasn't even there. What's an easy way to deal with that? Translate it, good. So you'll have p on the left, because we're not moving it. That 2l on the right is now minus 2l. That's going to equal my 2w, where I'm still trying to solve for what? W. We're on our way to solving for w, because all we now have to do is what? Undo the multiplication by the number 2. And how do you always undo multiplication? Divide both sides. On the left, you got a p minus 2l. That's a side. Divide this by 2, divide this by 2. Once again, by that cancellation property we reviewed in the beginning. I'm telling you, cancellation is gold. Haven't you guys seen us use cancellation over and over? Oh my God, that's gold. That's divide by 2. And what you have is p minus 2l divided by 2 equals the letter what? Now, let me ask you, did you get w by itself? Yes. So you can say w equals p minus 2l divided by 2, and you are what? Done. You're done. It's over. You just undid 2 operations. You translated and you divided. Okay, you okay with this? Anybody know, sometimes you look in back of the book, you might see a slightly different answer. I want to put a note here. What do some people do? Let's note. Do you guys know the distributive property? The distributive property just doesn't only work for multiplication, it also works for division. What I want to say to you, see the number 2 and this division sign? You know what this means? It means that numerator p minus 2l, that difference is being divided by what? 2. That means, since that division sign is under both terms, that means that both terms are being divided by what number? 2. Really by the division, distributive property, sorry.
Wouldn't you be able to cancel out the 2 though?
Yeah, well, which one?
Like the one up there?
Here and here?
No, up there, because you know how you got your answer? And that's what I did.
I understand. That's why I'm pointing this out to you guys. Don't do what you just described. This is the very reason why. This is p divided by 2. Do you have cancellation here? No. Why not? They're not the same things. P and 2 are not the same. But do I have a 2 and a 2 here? Yes. What operation is here, by the way? Multiplication. That's a small detail people overlook with the cancellation property. That has to be what? Multiplication. Has to be. Because what did I give you as that cancellation property? Right? Wasn't it triangle times square over triangle times what? Happy face. Isn't that square over your happy face? This is what people overlook all the time. This needs to be multiplication.
This is multiplication, so we cancel. So this cancellation property is applied here, and you now have as a final answer that W will be P over 2 minus L. This is another possible answer.
Oh, yes, answer.
Be careful. Never, 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 I mean never, never do two things. Never borrow money at 30% interest rate, or even 25%. Never. Could you borrow money at 0%? Sure, but they probably want you to pay it off in a year and don't be late on your payments. Go ahead and do that. Okay? But don't borrow money at 25 or 30. That's one thing you never do. What's another thing you never do? Don't cancel these 2's here. You can't cancel these 2's here. You cannot do this. Does anybody know why you can't do that? Because that is subtraction. That's right. That operation has to be multiplication for you to cancel. It's not. It's what? Subtraction. So what I'm saying is, don't do what you did, because you might, if you start doing that, and even if you wrote down the right thing, you did something wrong still, and you're getting used to reinforcing a wrong, bad habit, and that's not a good thing. So I'm going to say